Okay, everyone, welcome back. We're going to move on to activity 2. We are in module 3, topic 3, lesson 1, quantities that change. When one quantity depends on another in a real world problem or situation, we call it the dependent quantity, and the quantity on which it depends is called the independent quantity. The variable that represents the independent quantity is very aptly named the independent variable. Same with the dependent quantity is the dependent variable. Can you remember this? Often, like kids, you guys are dependents of your parents. You depend on them to buy your food, to provide your housing. You are dependent on them. They are the independent adults in the house, and the things that they do cause a change in you. Their actions or inactions can affect you. So you are dependent and they are the independent. So if we think back to the um, graphs that we matched up, it says to consider the scenarios from the previous activity, use the team party scenario to answer each question. Which two quantities are changing in this situation? If you remember in that one, it was the number of cookies and the number of teammates. And then it says which quantity depends on the other. So did the number of cookies determine the number of teammates, or did the number of teammates determine the number of cookies? Yeah, so the teammates, however many teammates there were, was the deciding factor on how many cookies everybody got. So this is the dependent, and this is the independent. Another way we can say that is the number of cookies everybody got depended on the number of teammates. So that's literally this answer here as well. I'm not going to rewrite it all. We're just going to draw a nice arrow there, and I'm going to put the label there. Okay, and in case you're wondering, we are on page 466. It says define variables for each quantity and label them. So I'm going to do that up here as well. We already labeled them as dependent and independent. So this we would just give it a C for cookies and maybe a T for teammates. So that answers all of that page. So you'll always ask yourself which quantity depends on the other. Okay, moving on. So Noelle, she had the 10-gallon per minute draining from a 200-gallon fish tank, and she came up with an equation, W equals 200 minus 10T. So the first question, 2A, says, what do the variables W and T represent? So what do you think? W is pretty easy. That would be water. Now, a lot of people want to say that the T is for tank, but it's not. Think back to the question and what was going on in the question. In fact, it even kind of gives you a clue right up here. 10 gallons per minute drained from a 200-gallon tank. So per minute, T would be time. Which two quantities are changing in this situation? It's the same. I'm not rewriting it. We're just going to draw arrows there, water and time. C, which quantity is the independent and which one is the dependent? So did the amount of water depend on the time, or did the time depend on the water? So think about that for a second. Try to come up with an answer on your own. So which one changed based on another? So the time was independent. Just going to put a capital I for independent. And the water was dependent. So as the time increased, the water drained more and more. So it wasn't the other way around. The amount of water didn't determine the time that had passed. As time passed, it determined the amount of water. So that answers both B and C. Okay, so for the rainy day, we had the amount of rain that fell and the time that passed. So which one is which? And if you're not sure, you can pause this and dig out your graphs that we had. Anything along the x-axis is the independent variable. And it's always going to be that. X-axis is independent. So on that rainy day, time was on the x-axis and the amount of rain, abbreviating amount there, was the dependent. What about the toy rocket? Remember the graph looked like this? And down here we had seconds, and we had the peak at 8 seconds. Remember, this was not the path of the rocket, but rather the amount of time it was ascending and then descending. So we had the height and the time. So again, time was independent, and then height was dependent. Movie and game rentals. Based on the way that the graph set it up, we had the total cost and the amount was $2 per game. So the number of game rentals and then the total cost. So along the x-axis, we had, you guys remember? We had the number of rentals, the number of game or movie rentals. And then that caused the cost to change. Now, someone has made a really good point in class today. They made a good point that if you knew how much money you wanted to spend, if you knew in advance that you had, let's say, $20 to spend, that would be the independent variable. If the amount of money you had to spend was $20, then that would decide or influence how many video games you could rent. So this would be the number of video games, the number of rentals. If you had $20, you could only rent up to 10 games. If the cost isn't an issue, if you're just going to go in and pick out whatever you want and pay whatever they tell you, then the number of rentals is independent and the cost is dependent. So it depends on how you're looking at it. And this is actually going to be the focus of the rest of the lesson as we move forward after this one. So t-shirt sales, we had the number of t-shirts and then the total cost. So did the number of t-shirts determine the cost, or did the cost determine the number of t-shirts? So the t-shirts determined the cost. Excellent. Any questions? If you have a question, send me a chat. I'll try to get a response to you as soon as possible. I know you may be watching this when you're at home and not feeling well, but if you have any questions, please reach out and ask me. We're going to move on to activity 3, but I'm going to put that in a separate video so that they upload faster. So we'll see you in just a moment on a new video.